Now, today we're going to be talking about understanding the benefits of composite manufacturing, what types of composite manufacturing out there, and as it relates to simulation, how can we actually simulate the fiber orientation and the structural impact of these sorts of composite materials. All right, so a quick outline here. First of all, we're going to be going over what are fiber reinforced polymers, the different types of them, and what are the different processes related to FRPs. We're going to be going over specifically in this meeting about compression molding and resin transfer molding, two processes that have really boosted in popularity over the last 5 years or so. And then I have a couple of case studies that I'd like to show specifically for resin transfer molding, as that is kind of an unknown in the industry right now, but we have actually worked quite a bit on resin transfer molding from a validation standpoint. Again, if you do have any questions throughout this session, please keep your microphones muted, but you can certainly send those through the chat section. We'll answer them at the end of this meeting. All right, so first of all, what is an FRP, a fiber reinforced polymer? There's a bunch of different types of fiber reinforced polymers out there. And looking at this graph, we have mechanical properties or structural strength over here on the y-axis and the relative fiber length, or what we call the fiber length ratio, L over D, of the different fibers. So we have unreinforced polymers. Obviously, these are just kind of the virgin polymer. There's no fibers or any sort of fillers involved. But when we introduce the short fibers, we do get a small boost in the mechanical properties, and we do actually get a little bit of complexity introduced into the flow based on the interactions of the fibers with the polymer, and also based on the interactions of the fibers with one another. With long fibers, we get a similar complexity, but even an added an added complexity on top of that, where we actually have the fiber length potentially changing as the fibers flow through different sections of the part. Sometimes they can break, they can undergo larger amounts of stress that will cause the fiber lengths to be different, and that variation of fiber length can actually impact your mechanical properties. So just an added layer of complexity, but the fact that they're long fibers really gives us that even a higher amount of rigidity. Ultimately, as the way you can think about fibers, if you're not familiar with fiber reinforced polymers, the way you can think of fibers is almost like rebar in concrete. The reason we use rebar in concrete is to kind of compensate for the shrinkage